Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
And before we get into this week's episode, we wanted to let you know about a couple of upcoming events. Dylan Martello, who is a Passive House consultant here at SWA, and is really instrumental in putting this podcast together, helping to produce the podcast. He's going to be speaking at both of these conferences, and he'll give you a little bit of info about them.
Thanks, Rob. The first is Building Energy NYC Conference, taking place on October 3rd and 4th in New York City. The conference, which is presented by Northeast Sustainable Energy Association, or NESEA, N-E-S-E-A, has become a staple for professionals and practitioners in the field of high-performance building, energy efficiency, and renewable energy. We have been to the Building Energy conferences for many years now, and my colleagues and I are looking forward to returning for another great event. Visit nesea.org for more info.
Yeah, I've been involved with NESEA for 20 years or so, and really good people, and I've learned tons at NESEA conferences over the years.
Next is the North American Passive House Network Conference and Expo, taking place at the David L. Lawrence Convention Center in Pittsburgh, PA. Join us October 17th through the 21st, where we'll be speaking on a variety of topics related to Passive House. Visit naphnconference.com for more info.
Thanks, Dylan. This week we're talking about zero energy buildings, ZEBs, which is an acronym probably a lot of people hear more or see more. I certainly do. It's a big topic. We don't get to the bottom of it, but we do our best. I'm talking with Paula Zimin, who is Director of Sustainable Building Services here at Stephen Winter Associates. She's an RA, but also does really a lot of energy modeling, and she focuses on larger buildings, larger multifamily buildings, commercial buildings, and institutional buildings. And I'm also talking with Karla Butterfield, who is a Sustainability Director here at SWA. And she's all about residential, from single-family residential homes all the way up to large, tall, multifamily buildings and everything in between. And she does a lot of work with certification programs. Zero Energy Ready Home, which we talk about here, LEED, National Green Building Standard, among several others. So this episode, really, we talk about all types of buildings, small to large, different programs, different systems, different paradigms, and even, I think we start the episode with a discussion of different meanings of zero energy buildings. What does this really mean? So let's get to the interview. Welcome, Karla. Paula.
Thanks, Rob.
Thanks for being here.
Great to be here, Rob.
So zero energy buildings is a big topic. It's, I think, even getting into kind of the mass media. I see it in newspapers and stuff, not only in the magazines and journals and conferences I've been going to for a decade or whatever. So it's a growing topic, growing in popularity. And you guys have certainly dabbled in it, and it's a growing trend. Yes?
Yes, I would say it was a buzzword 10-ish years ago, where most people in the industry knew what zero energy buildings or zero energy construction meant. And then went through kind of a controversial period of what does that really mean and what do we really call it?
That was going to be my next question.
Okay, but you're right. It is in the mainstream now, and most people who are at all familiar with the built environment know what zero energy means.
So what does zero energy mean, Paula? Zero energy building.
So I think in my world, because I work more in the commercial sector and larger buildings, zero energy buildings gets limited to a building scale, which can be very difficult to do. So in my world, I think that we're approaching zero energy on a broader scale, at the community scale.
Okay.
So there's certainly a low energy building focus. There might not be the ability to get to zero energy, but there is certainly the drive to how can we as a community or a larger set of buildings get to zero.
So, I mean, it seems that at the core level, we're talking about very efficient buildings, very low energy needs, be it electricity or fossil fuel or wood or whatever, low energy needs, and you can meet all of those energy needs with renewable energy, wind or solar or whatever. I mean, that's
right.
That's kind of the general idea.
That's the general idea. A lot of people will argue there's no such thing as a zero energy building because of the fact that you are using a fuel. And so it's really a net zero or net neutral fuel building.
So that was, yeah. So that I've had people like jump down my throat where I
Right.
say zero energy building and they say, no, net zero energy building. And I actually seriously don't understand that distinction.
Right.
But
And
have
so,
you-
and then saying net zero energy also is somewhat offensive to some people. So they want to say, you know, what we are is we're neutral with fuel. So one fuel offsets the other.
So if you use some natural gas, you generate even more electricity from PV or
Right.
something to
Exactly.
offset that natural gas?
Right. And that's easier to do in low-rise buildings, especially single-family buildings or really small multifamily buildings, like Paula indicated. Harder to do in more commercial or high-rise buildings because you don't have enough room for that PV to offset. If it's
Okay.
on your roof, there's a lot of other solutions for that too. I'm sure you're going to ask that question in a bit.
Yeah, a lot of the controversy is that even though you're a net zero building, you're still using the grid. And how does the grid get its energy? Usually through fossil fuels. So if you're really talking about a carbon neutral building, that's very hard to do from the building scale, unless if your grid is carbon neutral. So unless if your grid is hydro or some other non-fossil fuel source. So you could also be off the grid potentially to be at carbon neutral. So it's a difference between a net carbon neutral building versus a net zero energy building and your relationship with the grid.
Okay. So as a catch-all term, zero energy buildings, you're going to get disagreement about that.
Yes.
No, we're not
It
going to
all
today
comes down to
come
how
a
you want to define
industry-
it. You have to define what zero energy means to you, whether it's zero carbon, net zero, or some other sort of definition. If it's
Zero energy
okay.
cost,
Right.
which is they're not necessarily zero energy cost.
I think to keep pushing this into the mainstream and have it be more than a buzz phrase, it has to be something catchy, which is why zero energy or zero energy buildings has caught on.
Okay.
Even though we can see there's many, many layers to that.
All right. Well, there's actually some papers maybe we can include in the show notes, that different definitions and how, if people want to dig into that more.
Sure. And I think that one of the definitions is either the modeling approach or the actual utility bills after
Oh,
a certain.
good distinction.
Right.
So, and you guys both do a lot of energy modeling.
Right.
And Karla, you're, as you said, you focus on residential, single family, all the way up to larger multifamily.
Right.
And Paula, you're on kind of larger multifamily and also commercial institutional.
Right.
And Karla, single family, it's easier with single family.
It is.
And you've worked on several,
I've worked on several single family or duplexes that have done either approaching zero or zero energy, and we have verified it in a couple of different ways, both with an energy model and then with 14 to 16 months worth of utility bills to show that they actually were energy cost neutral or negative in some cases. And for other projects, just with the energy model that either predicted the usage and then tested out and gave it what we all know is the HERS index, the Home Energy Rating Score Index, to indicate that it could be a zero energy building.
So with the HERS, I'm sure we'll get into this in future podcasts, but the HERS index, 100 is kind of like a mediocre average home, and 0 is theoretically a zero energy home. So lower is better.
Lower is better. And in the Northeast, where we do most of our consulting anyway with the zero energy stuff, we have to get down somewhere around 40 or maybe even 35 to get to kind of the sweet spot to then put on PV to get the HERS index to 0.
All right, interesting. So what do you do? What those homes that have a HERS index of 30 or 45 before any renewable energy?
Right.
What systems do you see?
Right. So, and we see this in the single family homes, the duplexes, and also the low rise multifamily. We've done a couple of projects, one in Ithaca, and we have a few more on the drawing board that have been successful, from 15 units, 4 stories, to 60 units and 3 stories. Strategies are kind of similar. It's usually a high efficiency assembly, and that can be either a double stud wall so that we're doubling up on the insulation value, or some rigid insulation on the exterior of the wall that's then put siding over it, so obviously you don't see it. So that would be a high efficiency or a high performing wall assembly. And then in most cases, we're looking at triple pane windows. And then the roof in our region has to be really well insulated, sometimes as high as an R90. In some cases, we can be closer to 60, but we've had projects that have had to go as high as 90 in the attics or on the flat roofs.
These are like passive house specs? Were some of these passive houses that got to zero energy?
Yeah, so the Ithaca project I mentioned, the rest of the community, the duplexes and single-family homes, some of them were passive house certified, several of them were LEED for Home certified, all of them were Energy Star, Indoor Air Plus, and the DOE Zero Energy Ready Homes program.
All right.
And then the multifamily, the 15 unit, followed all the protocols but didn't go through the certification processes.
Okay. So programs. That's another question for both of you. Zero energy programs. You mentioned Zero Energy Ready Home, which I always stumble over that name.
Right?
That's DOE.
Yep.
And that is, in a nutshell, can you give us
In a
quick-
nutshell, that is a high-performing apartment building or home that has a HERS index of 45 or lower.
Is that a
before
line? Is that a hard
PV.
line, or is that like an approximate line?
I'm pretty sure that's a hard line for at least in our zones that we work in.
Okay.
I'm not sure if it changes in zones 1 and 2.
So kind of a practical line. You haven't seen it really work. All the zero energy ready homes have had 45 or less? Or it's like you just have to get 45.
You don't
in
know
order-
the answer to that question now that
Okay.
you're asking me at point blank, because some of the it also goes with some of the state programs. So NYSERDA has a hard line for,
Okay.
and then Connecticut does as well for the tiers that in qualifying. And
All
if you
right.
qualify for those tiers, you also have to be zero energy ready. So
gotcha.
So anyway, it gets kind of an alphabet soup of confusing.
Yes, okay.
But yes, there's the DOE Zero Energy Ready Homes, which can apply to anything that can be Energy Star labeled. So it has to be Energy Star labeled, it has to meet Indoor Air Plus requirements, and it has to meet a pretty stringent domestic hot water delivery requirement, which is a bit tricky for multifamily. So that's what a ZERH is. And then there's another...
And Indoor Air Plus is an EPA air quality certification.
It is.
some
It's a
guidelines.
companion certification to the Energy Star program.
Okay.
And then there's the Living Building Challenge. There's an energy pedal in the Living Building Challenge. There's also a separate pathway for zero energy certification in the Living Building Challenge. And we've had one project achieve that.
Single family?
Yes.
Cool.
And that program can also apply to any building type, commercial, residential. It's open.
The
The
living-
requirements are very simple. You have to demonstrate zero energy.
So it's
They're
not
much-
modeled, it's measured.
Yes,
for
it
the
is. It's
liv-
measured.
For the Living Building Challenge?
Yes.
Okay. And so larger buildings, Paula, either of you, have you worked with multifamily buildings that have gotten a
That have
zero energy pedal? Or
zero energy, larger buildings, not on the commercial side, multifamily side.
So the push with the multifamily side has been everything that pushes this really are incentive programs and financing, either requirements
Okay.
or incentives through financing. And so
So people aren't, in your experience, people aren't just trying to get to zero. They're not hordes of people trying to get to zero energy.
there are not
just
hordes
because.
in general, and there certainly are not in the multifamily sector.
Okay.
It is pushed for the affordable multifamily developers by their financing.
Okay.
And the requirements that come in the state of Connecticut and Pennsylvania specifically have enhanced the application process. If you do passive house, you get more points. And since it's such a competitive process for financing, those points become very important. So that's where we've seen an uptick in passive house, which is a great pathway to zero energy building.
Okay.
Yeah, the problem though with getting zero energy in multifamily buildings anywhere from like 3 to 4 stories and above is just that you have a much larger building volume to available rooftop ratio, and the ability to offset all of your energy use within that limited area. It's just a matter of numbers. You just don't have the amount of area that you would need, which is why you would, if you were interested in a zero energy building, you start thinking about buying green energy from a portfolio, from a community, distributed energy resource.
Okay. I worked on one. I had a very small role on one zero energy multifamily project up near Albany, and we just did some consulting on the HVAC in the units. He wanted to get away with very, very simple heating and cooling systems, but I think they I think it was 3 or 4 stories, 20.
That's about the limiting range, 3 to 4
20
stories.
something. But they had, I think the PV was like covered parking, PV covered parking, so that,
I'm
it's not a building,
surprised.
it's kind of the site.
I am surprised that we don't see that more often. The covered parking, PV over covered parking, particularly in the more suburban areas, maybe it's the cost of the additional structure that you would have to install, but that would be a great place to put PV for our multifamily buildings, 3 to 4 stories, or otherwise garden style apartments. But it isn't often seen.
I think it's just not really. It's not that it's not accepted, but it's not something that we see in the Northeast. I see it a lot more down south. I've seen covered parking in Florida quite a bit, and I think we have one project in Northampton, Massachusetts.
Okay.
Is that where Amherst and those schools are?
They're right around there.
Sorry, yeah.
Right around
okay.
there, yeah.
But they're looking so hard for places to put the PV because they are targeting zero energy for dormitory.
Gotcha.
And so they're lifting up above HVAC equipment on the roof, on pedestals for the PV, as well as on the carports. So when you think outside the box, there's places for it to go. But that's a pretty rural area up there.
Yeah. Yeah.
Yeah, you have to have the space for it.
It's not going to work in Manhattan.
It's not going to even work in Cambridge. We have another project
Yep.
in Cambridge with a university, and when they came to us, one of the first goals was we want to be zero energy. We want this 7-story dorm to be zero energy, and quickly found that as hard as we were working with the envelope and the model, which Paula's working on, they weren't going to reach zero energy.
Not within the building footprint. They'd have to look beyond.
Right.
Well, and this dorm also has a cafeteria and some other amenity spaces,
All
and
right.
so the usage is pretty high.
Right.
So, Paula, when you get into bigger multifamily buildings, how does the modeling change? How do the programs change?
In terms of zero energy, similar to what Karla was saying, there's really only the International Living Futures PEDAL certification for zero energy buildings.
As far as like programs, as far as programs go?
There's a voluntary self-reporting that you can report to the National Building Institute, NBI, to claim that you are zero energy, and that can be either modeled or actual.
Oh, interesting.
Yeah,
Okay.
but that's sort of your self-reporting. It's on you to prove it.
I see.
Yeah, but there's no other particular program in the commercial market.
Okay.
to
But
recognize it.
modeling tools are different for commercial
Yeah.
and big
Yeah.
multifamily than
So
residential.
whereas Karla often uses HERS software, REMRate primarily, we can use any number of ASHRAE approved or DOE2 modeling programs. We primarily use eQuest or OpenStudio for that modeling. The concept for zero energy is the same though, whether you do a single family home or do a school or an office building. You primarily just want to know what your loads are on the inside, balance out what the envelope needs to be, and provide a robust envelope, and then downsize your HVAC equipment and be thoughtful about your ventilation systems. And you at least can get to a low energy building, if not net zero, if you don't have the ability to install renewables on site.
So if somebody comes to you and says, one of these clients you've been talking about, we want a zero energy building, we want a zero energy dorm. First step is
Tell them that the residents cannot bring in extra refrigerators.
Or tell them that they're limited to 1 laptop per student.
I guess when I talked to Lois about passive houses, I mean, it was like it all depends on where in the design process they are. I mean, if they come to you very, very early, you can really focus on the design and the envelope, I assume, to get the envelope as good as possible, and modeling helps on that front.
You really have to model. You really have to model to understand the equipment that an owner anticipates in the building, to understand the schedules of that building. An apartment building is going to be different than a dorm because obviously the density is different in terms of people,
Right.
and the kind of equipment, families versus young 20-somethings in a dormitory, and the equipment that they can bring in versus a school, which might only have like 2 computers per classroom, or maybe a high school has computers in all their classrooms for every student. So the level of equipment can be anywhere across the board.
But ideally, it is during schematic design, if
Okay.
not definitely during design development. And the
Yeah,
model,
I would say even design development is almost too late.
in some cases, probably for the bigger buildings or the more complicated ones. And the modeling there should be continual iterations in the modeling as the designs are being developed, and there should be several plan reviews. Usually at 50% design development, at 100% design development, then again at 50 construction documents. And then after, when they do that really horrible thing called value engineering, which isn't really what it's supposed to be. So after a VE set or a VE session, we get our eyes back on the plans again to make sure that none of the critical elements have been taken out and not properly replaced.
And so you mentioned the downsizing the HVAC, and that was something, that's one of these kind of concepts that I remember hearing talked about 20 years ago, but in practicality, rarely seeing. But that's, I think, coming into play. Yeah, I mean, you can say, if you go an awesome high R airtight envelope, there are opportunities to save some money on the HVAC.
And the equipment is available in the sizes that are appropriate for the single family homes.
Right.
So when we get down from, we might have seen a house that had load calculations saying they needed 5 tons for the cooling, and when properly calculated room by room load calculations, it comes down to 2 tons, and that piece of equipment is available. So that's great.
Okay.
But when it comes to the multifamily, where the loads are incredibly low on the high-performing buildings,
Like per apartment, you mean?
like per apartment, in most cases, this is going to be a per apartment situation because the owners very seldom want to own the utilities. They might be willing to own, say, natural gas bill for the domestic hot water for a central system, but they don't want to own all of the tenants' electric. So these are sub-metered or individually metered, which means that every apartment has its own heating and cooling source. And so to get those really small, that's when it gets tricky.
Gotcha. And on institutional buildings, commercial buildings, the loads are often like internal gains driven, not so much envelope driven.
Most of the time, we find that in commercial buildings or even the more dense, higher, bigger multifamily buildings, you don't really need more than about an R20 opaque wall assembly. We always recommend better windows, always recommend triple pane. The windows are always the weakest link in your envelope assembly. But what is really driving the energy of the building are those internal loads, are all the equipment, all of the people, all of the ventilation within the building that's driving cooling and heating loads. It's the envelope, it doesn't really keep too much out when you have to ventilate the building to the level that you want your building to be healthy, and you don't want to fight that. But that it's always a balance when we're talking about commercial buildings of how much ventilation do you want to provide, how healthy do you want the interior to be versus the energy use of that building, because more ventilation is going to be more energy.
Another reason why it's easier for smaller buildings, I guess, for single family.
Right.
Because it's really envelope driven rather than internal gains driven. So we mentioned schools, we mentioned colleges, but Paula, there's a lot of interest in like public schools and school
Absolutely.
agencies to go this way. Is
Yeah.
is that a whole different can of worms? Is that a
I think net zero certainly is possible, more so in public schools because it's very repeatable building typology, and I think that there's a lot of studies that are out
low
there.
rise typically,
They're
right?
Typically low rise. I mean, urban schools
Yeah,
are going to
right.
have a little bit more difficulty when they're approaching the 4 or 5 story. They have a smaller footprint that they can work in. But certainly in the burbs where you have a 2 or 3 story school, you can absolutely get to net zero fairly easily. But again, you do need to be cognizant of how you're designing the building, what the loads are of the building, particularly kitchens. We had talked about kitchens previously at that one dorm. Kitchens can have a very high load that can make it difficult to meet your energy goals.
And remember, we had the conversation about net energy or zero net energy or net zero energy. And so when you're talking about the use of the building, it has even come up with the dorm that we were just talking about of whether or not it will be open in the summer for camps. And so that changes the dynamic because normally universities are closed for at least a couple of months. The dorms are being used for a couple of months. And the same would hold true for a school. So easier in an annual period to show that you're zero energy.
Gotcha. You're generating lots of electricity if you have PV when you're not using
Correct.
much at all.
Right.
Yeah. Interesting.
And that introduces an interesting dynamic with the grid, because if your school, which is producing the most amount of energy in the summertime, is otherwise shut down, you're exporting most of that generated energy to the grid. And is there a payback with your local utility for that exported energy? Is there a benefit to you or not? And that could play a role if it's a financial decision.
Well, we've seen it play a role too with nonprofits, so senior care facilities deciding not to go with PV because they're already locked into a very low rate for what they pay for the electricity, so there's no payback there to go.
Right. Gotcha. Yeah, and that's getting back to something you mentioned earlier with the schools who have all this excess electricity in the summertime. Maybe that opens up opportunities for zero energy communities doing that.
Exactly.
Now
I think we really need to start thinking beyond just the boundaries of our buildings, and start thinking about communities and how either commercial buildings can use that exported electricity nearby and develop those relationships so that it's not necessarily a burden to the grid. Because as we see in California and Hawaii, there's a lot of renewable energy out there. It's too much at the wrong time, right? So in California, Hawaii, they really need to start talking about energy storage so that they can use that energy that they're producing, just not at the time that it's being produced. I think that'll start being part of our conversation as we start talking about these community district energy systems.
All right.
So we can maintain that all within our communities.
So how about codes? I mean, I've heard lots of talk about California mostly, but also New York, Massachusetts, trying to move to zero energy codes. Is that? Do you get what? I mean, what does that mean? I got to say, I've heard a lot more talk than substance on this topic.
Well, it's a little easier to do out in California, quite frankly, because the insulation goes a lot further, the PV goes a lot further. I mean, you need less insulation and you need a little more PV, and you can get to zero a lot faster in those zones.
Because of the climate?
Because of the climate.
Okay.
And that's not true everywhere in California for sure, but
in San Diego, yes.
where
you're heating and
I am
cooling.
zero energy in my tent. But yeah, it's definitely more of a challenge in zones 4 and 5, which is Massachusetts and New York State.
And 6, I think, right?
And 6, of course, yes, as you get up further north. Yeah.
All right. Yeah, the last I read that California was kind of backing off on the whole zero energy mandate and zero electricity as a first step. Is that yeah? Well, to be determined. But are you involved in New York policy or any other policy on the East Coast? I think you were talking about school authorities.
In New York City, they have developed the stretch code, which we anticipate in the coming months. The stretch code, I think, is trying to get to be 20% better than the current code. I'm a little bit skeptical on it because knowing how energy modeling works, the regulated load within our current code is already so low, and this percent better thing that we've done for so long is starting to be less effective.
Okay.
We need to start moving toward an absolute target of some sort.
Okay.
Similar to how Passive House has a target of 38, for example, for new construction. 38 source EUI. I'm sorry.
Okay.
Source energy use intensity.
So it's an energy per square foot.
And sort of an energy per square foot,
Okay.
right, on the source basis. So we're however much energy goes into generating the electricity from the power plant that goes into that calculation.
All right.
I don't know if 38, I don't think that 38 is the right number for all building typologies, but I think we need to start talking about absolute numbers as opposed to this percent better, because this percent better starts to just be an obscure number that is very difficult to get to potentially. We've been finding that the percent better could be much more restrictive than a Passive House, for example.
Oh, really?
So you could design a Passive House building that doesn't necessarily meet stretch code. That's a problem.
Yep, that's tough. All right. Yeah. Jeez. So if we come back in 5 years and talk about this again, what will we be talking about?
We'll probably be having a very similar conversation. However, we'll have many more examples.
All right.
I do think we're going to see the construction of some of these near zero or, the multifamily is just not going to get to zero, but so I don't know what we're going to call them, but we're going to see more construction. We're going to see the fear factor go away a little
The
bit.
fear factor of, zero energy, it's way too expensive, it's way too weird.
Yes, this is
Okay.
not what we normally do. We can't build like this. It's outside of our, the way we do things kind of thing. We're already seeing that change with sort of the second phase of developments that have done either passive house or close to zero, or just getting to a HERS index of 40 to 45, which is a big jump for some developers in multifamily that might be used to 20 points higher in a HERS index. So we're moving in the right direction. And I think hopefully we'll get the terminology down so that we're not spending half of the podcast talking about the words.
Without coming to any consensus.
Exactly.
Yeah, I think terminology is hopefully what we'll see a change in my industry, in the commercial world. In the commercial world, we often say high performance buildings, and I think we need to change that nomenclature to be low energy buildings or low carbon buildings, because a Maserati and a Ferrari are high performance cars, and they ride really well.
I see.
But what's their MPG? Right? So we need,
and they are a little pricey.
We need the smart cars. We need, the little electric cars or hybrid cars or something a little bit different. That's going to be our solution. We need to change it from high performance.
Although I would argue smart car doesn't really do it for me either.
You mean you're talking about not a car that is smart, but the
little itty bitty
shoebox.
shoebox cars, yes.
Gotcha.
Yeah.
Well, hopefully we won't get too many emails about that. People loving their smart cars. All right, so it's not going to become standard practice, but people are going to be much more familiar with it, and
comfortable with it.
And we'll have maybe metrics that are more meaningful.
I think so.
Nice. Cool. Anything else on the ZEB topic, or we'll talk about it again in 5 years?
Well, maybe sooner than 5 years, but...
Great.
Yeah.
Thanks a lot.
Thanks, Rob.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.